Let me give you another example. So if I were to ask you to integrate this, giving you the choice of using our old method or using substitution, so let u equal something. You see, our old method here would be for us to make an initial guess in such a way that when we differentiate it, it would give us this thing here. You see, this here, our method, our old method works well when it's nice and simple. But in this case here, how would you make an initial guess? You see, our old method here breaks down because this is a lot more complicated. So here is why we should use substitution. So let u. So we should imagine this as being in a bubble here. So let u equals this thing here. Well, if u equals this thing here, then du equals, now differentiate this, it would just be 1. And then it will be dx here. Well, 1 times dx is just dx. So if u equals this, then du equals dx. Okay, so let's u equals this, and then du equals this. So now we can put this into here. Okay, and dx here is just simply du. Okay, so we can put this into here. So this complicated thing here becomes slightly simpler. Okay, so now this thing here becomes this thing here, and then now looking at this here, so from here you can jump to here because hang on, x squared equals this. But don't forget, you see, this is the advantage of using substitution. Once we've made this substitution, we can jump to this. We'll add 1 to both sides, so that would be u plus 1 equals x. This is the advantage of using substitution. So now we want x squared, so square both sides. So that would so now x squared equals this thing here. Don't forget x squared here. Hang on. Don't forget x squared here. Don't forget x squared here is this thing here. So we can now substitute this into here. So from here, that would then take us to here. Just because we can rearrange this. That's the advantage of it. So u plus 1 squared equals x squared. So we can put this into here, giving us this. Okay. So you see, this here, our old method of guessing. Our old method of guessing works well when it's nice and simple because it's nice and fast. But when this is slightly more complicated, we've got to use this. Okay. Well, anyway, from blah blah blah, it would take us to here, and then now it's more blah 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 here. So multiply this out here. So that would then give you this. Okay, and then oops, hang on, and then this times this times this times this, that will then give you this, and then now it's just normal integration. It's blah blah blah, that will then give us this. Okay.